presenting a PBL project about blood typing and blood donation. In this project, we learned what blood types are, how they are determined, and why matching blood types is important for safe blood transfusions. We also carried out a blood typing activity in the lab to determine our own blood types.
After our lab work, we created educational pamphlets to raise awareness in our school about blood types and blood compatibility and the importance of donating blood. Through this project, we learned how science is connected to real life and how understanding blood types can save lives. We will now present our work and explain what we learned during this project.
The slide shows the main components of blood after it has been separated. The yellow layer at the top is plasma, which makes up about 55% of the blood. Plasma is mostly water and carries nutrients, hormones, and antibodies that help protect the body.
The thin white layer in the middle is the buffy coat. It contains white blood cells and platelets, which help fight antigens and stop bleeding. The red layer at the bottom contains red blood cells, which contains 45% of the blood and carries oxygen throughout the body.
Blood types are different classifications of human blood. They are determined by special markers called antigens found on the surface of the red blood cells. Based on these markers, blood is grouped into types such as A, AB, O, and B.
Each type can be positive or negative depending on the Rh fact. The body can recognize its own blood, so this is why matching blood types is important for safe blood transfusion.
Red blood cells may have special proteins on their surface called antigens. Blood plasma contains antibodies that recognize and react with these antigens. The combination of antigens on the red blood cells and antibodies in the plasma determine a person's blood type.
Each blood type has a specific combination of antigens and antibodies. Blood type A has A antigens on red blood cells and anti-B antibodies in the serum. Blood type B has B antigens and has anti-A antibodies.
Blood type AB has both A and B antigens and no antibodies against A or B. Blood type O has no antigens on red blood cells and has both anti-A and anti-B antibodies in the plasma.
A blood type is determined by using a small sample of blood. The blood is mixed with special antibodies called anti-A, anti-B, and anti-D. If clumping called agglutination occurs, it means that the matching antigen is present on the red blood cell. By observing which samples clump, the blood type can be identified.
This slide shows how a person's blood type can be determined using the slide method. First, a small sample of blood is taken and put on a glass slide. Then, anti-A, anti-B, and anti-D antibodies are added to separate drops of blood. The drops of blood are mixed with different toothpicks in order to avoid contamination. Finally, the blood is observed for clumping called agglutination. Clumping shows which antigens are present on the person's blood, determines its blood type, and identifies whether it is positive or negative.
This video shows the blood typing lab activity we performed in school, following the correct steps to identify blood types using antibodies.
Step 1. Sterilize the finger with alcohol.
Step 2. Use a sterile lancet to prick the finger.
Step 3. Place 3 drops of blood on a slide.
Step 4. Add anti-A, anti-B, and anti-D antibodies.
Step 5. Mix each drop with a clean toothpick.
Step 6. Check for agglutination, clumping.
Antigens act as identifying markers, while antibodies are the body's defensive proteins that recognize and attack foreign antigens. A donation is safe only when the recipient's immune system will not react against the donor's antigens.
The golden rule of blood donation states that the antigens found on the red blood cells of the donor should not agglutinate with the antibodies found in the plasma of the receiver.
This table shows which blood types can donate to others and which types they can receive from. Some blood types are more flexible than others. For example, O negative is known as the universal donor because it can donate to everyone.
While AB positive is known as the universal receiver because it can receive blood from all blood types. Knowing blood compatibility is very important to make sure blood transfusion is safe and does not cause harmful reactions.
Blood transfusion are medical procedure in which donated blood or blood components are given to a patient through IV line.
The need for blood transfusion. A transfusion is ordered by a doctor when a patient has significant blood loss, surgery, trauma, low platelet count, certain medical conditions, problems with blood clotting, needing plasma to improve oxygen delivery to tissues, shortness of breath, chest pain, rapid heartbeats.
Before giving blood, the patient's blood type, AB, AB or O, and Rh factor is checked. Then the lab performs a cross-match to ensure donor blood is compatible and won't cause reaction. They reduce the risk of transfusion reaction and ensure the safest possible match for the patient.
Preparing the patient. An IV line is inserted usually into a vein in the arm. The patient is informed about any possible symptoms of reaction. Preparing the blood. Depending on the patient's needs, different blood components may be used. Red blood cells, which are the most common, platelets, and plasma. The blood bag is connected to the IV line and the transfusion begins slowly to detect any reactions. The nurses monitor for reactions such as fever, chills, back pain, breathing difficulty. 1 unit of blood takes 1.5 to 4 hours to complete the transfusion.
After the blood has infused, the IV line may be removed or kept for medication. Vital signs are checked again to ensure the patient is stable. The transfusion site is checked for pain, redness, swelling to rule out infection. The patient may be observed for delayed reactions.
Benefits of blood donations: saves lives, essential in emergencies, helps patients with long-term illnesses, improves community health, health check for donors, and encourages awareness of blood types.
Hello, everyone. So thank you for the interesting set of presentations that you gave. I like the idea that there was a lot of interactive elements in those presentations, especially how you actually distributed the information in a very nice way in the 4 different presentations, tackling the elements of blood, showing how the test is actually being done, how you can determine the blood type. In one of the presentations also, you went over blood transfusion, why is it important, and so on. So I'm going to try also to give some background regarding blood in general, then walk you through why blood transfusion is important, why do we need it, and then finally some questions regarding myths related to blood transfusion. So as you said, when we look into blood and blood donation, this is a very important kind of an activity that people can do, which costs nothing, but at the same time, it can save lives. So 1 blood transfusion actually can save the life of 3 people with different disorders, and this is what we're going to look into. You already said the main elements and identified the main elements of blood, being it plasma, being it red blood cells, all the different types of antibodies, which is in the heart and the core of the test that you need to do in the lab in order to make sure that at the end you don't really cause death by simply transfusing the wrong blood type. For those who were not involved in the project directly, we look into the blood type because of antibodies. And antibodies are important because if we do a wrong blood transfusion, we will have antigen-antibody interactions in the body, and this eventually can lead to death. So as your colleague said, when you look into the blood elements, you have cells, you have proteins, you have clotting factors, and all of these are important, and it tells you why we cannot actually reach to a point where we can ourselves manufacture blood, because it's really a combination of so many different elements that you cannot yourself or technology cannot really ensure having all of these different elements in the way that we actually have in our own blood. In other words, there is no synthetic alternative that we can use and that can really take over the importance of human blood. And this again tells you why hospitals entirely rely directly on us to actually donate blood. So donating blood is then very important because we do not have any alternative. What happens once you actually go and donate blood? Of course, before you donate blood, there are a number of elements that people check to make sure that you are able to donate blood, like, for example, your weight, your health, your hemoglobin. All of these are important checkpoints. Diseases that you might have had, especially viral infections, these are things that people check with you. And then if everything is fine, and this doesn't take really too much time, from the time you arrive to the hospital to the time that they decide you're fine, you can donate blood, it will only take like 10 minutes or so, okay? Once everything is cleared, of course, you donate the blood. It's just 500 ml of blood, so it's not really that huge amount, and you can easily, in a very short period of time, regenerate the blood that was actually the blood that you donated. And then there are a number of tests. Microscopy is important, and then people start checking if the blood has any indication of infection, especially HIV, very important. So you need, in the hospital, they need to check if the person has HIV, hepatitis, different types of hepatitis, hepatitis B and C. If you know, hepatitis is a disease, it's a viral infection that actually targets the liver. So this is again something that you need to check for, because you don't want at the end to give someone a blood that has any of these kinds of infectious agents. And there are so many other important tests. And this tells you also that blood is not going to be given to anyone unless we are 100% sure that it is safe. It doesn't have any of these threatening factors. Then after that, it will be split into 3 different elements. As you said in your presentations, you have blood plasma, platelets, and erythrocytes. Okay, so erythrocytes are actually the red blood cells. So they split them by centrifugation. Okay, and I'm not sure if you know what centrifugation. It's an equipment that we usually use in the lab, and it ends splitting blood into different elements depending on the molecular weight. So that's why you end up seeing those 3 phases, the 3 layers that you have shown also in your presentation, and that is also shown on the slide. So erythrocytes, obviously red blood cells, are the most dense. So these are the ones that will precipitate, and then you have the other part or the other layers. So I'm sure you know the importance of each element in blood when it comes to survival. Red blood cells, you said it, also linked to oxygen. Plasma has clotting factors and proteins. clotting factors are important. If you're injured and you do not have enough clotting factors, you end up bleeding. So this is also important point to bear in mind. And also you have platelets that are additionally needed to make sure that people do not bleed. Now, who needs those different elements? Why did I say at the beginning that when you donate blood, you actually end up saving at least 3 lives? Because red blood cells are given to trauma patients, so you split them into the different layers, and then red blood cells are kept for trauma patients, surgery, people with anemia, cancer, different types of disorders. Plasma is actually given for burn victims, liver disease, people with massive bleeding because it has the important elements to help stop bleeding, and then platelets, again, cancer patients, transplant patients, and so on. So by giving only 500 ml of your blood, you're actually ending up with saving 3 different types of people with different cases and so on. So this is really important to bear in mind that you don't just give the whole blood to another person, but rather you split it into different parts. And this shows you the percentage of people linked to their cases and that they require always blood transfusion. So 27% goes to cancer treatment, 21% to surgical, and so on. So from this, you understand really the importance of blood donation and how it actually helps in a way or another to save lives. Now, what do I need to know in order to determine whether I can donate blood or not? First of all, your age has to be 18 and above. So it's too early for you to donate blood, but eventually, down the road, within a few years, all of you, if you are healthy, you can actually be a good volunteer to donate blood. And of course, as I said, before they take blood, they do the needed test, but again, you need to volunteer in order for them to check these things. So what are the things that I need to avoid if I'm planning to give blood? Okay, if I'm planning to donate blood, what are the set of things that I need to avoid? First of all, before giving blood, of course, you shouldn't take aspirin because that causes bleeding. So you cannot go and donate blood while you are on such drugs. Then refrain, of course, when you are 18 and above, people donating blood should not really drink a day ahead, should not have alcohol in their blood, okay? And then avoid, of course, smoking. And the other important point is avoid eating greasy food, so hamburgers and so on. Why? Because this actually interferes with the overall body metabolism. And when they split the blood into different elements, plasma could become turbid if ahead of time you were really binging over a lot of fatty foods. So these are the set of things that you need to tell people. So at home, when you go back and you tell your parents you need to give blood, and then you need to tell them, but before doing so, you need to make sure that you avoid all of these important things before you are ready to donate blood. After donating blood, you need, of course, to relax. You take a lot of fluids, water mainly. Avoid physical activity, so don't donate blood and go to the gym immediately. So try as much as possible to relax and, of course, not smoke immediately after donating blood. This is just to make sure that you do not suffer from any consequences, although it's very rare, really. If you are a healthy person, trust me, nothing will happen. Now, the other thing that I want to discuss with you, first of all, I want to ask a question, especially the group or the set of students who worked actively on this project. So, first of all, what is the most common blood type? So how many says it's A plus, and how many says it's O? A plus. Let's start with A. Okay, so you think that the most common type of blood usually is A? It is O actually, yes. The majority is O, so this is actually one of the most common types. So which is the type that is rare to find? Yes, definitely AB. And which is the international donor? O minus, excellent. So the person that can donate without any fear is a person who has the O negative type of blood. If AB patient or if an AB donor, let's say, AB people take blood from everyone, right? It doesn't really matter. Why would a person with an AB type blood end up really donating blood? Why do we need to take blood from AB people? Since an AB patient can take blood from, no, the AB, if I am an AB blood donor, any other AB recipient can take A or B or O. But why would someone with AB blood type need also to donate blood, knowing that people with the AB blood type, they can take any other type of blood. They don't need really to have specifically AB. It's basically, and you said it actually in your presentation, because we need the plasma, right? And the plasma of the AB people is unique because we don't have antibodies in that plasma. So that's why, although AB, recipients, they can take blood from any other donor, but they cannot receive plasma. So that's why we consider this a unique and also a much wanted type of blood. So the message here is that no matter what is your blood type, we always need it, okay? Regardless whether it's A or O or AB or whatever, all types of bloods are needed, okay? Now, let's go over some actually questions which are, if you want, a kind of set of myths that we have when it comes to blood donation. I'm going to ask the question and then please raise your hands and tell me if you know this is true or not. So the first actually myth, you can run out of blood if you donate blood. Let me see how many says yes and how many says no. No? Okay, how much blood actually do you donate? 500 ml, so this is not really too much blood for you to eventually really reach to a point where you donated all your blood. So the other myth, only people with rare blood types should donate, and this is what we have just discussed. No, this is not true. Every single type of blood is actually needed because of so many different reasons. Is blood donation painful? So the only thing that happens is what? The only pain that you will feel, which is few seconds, is the needle. But in general, even while you are donating blood, and I did it, you don't feel anything, okay? It's just the needle stick at the beginning that is a bit painful, but it's fine, you can survive through it, and then all the rest, there is no pain associated with it. If I have O blood, I can give to anyone, so I'm not needed. Is that true? Yes, of course. As we said, all different types of blood, regardless of the group, they are needed, they are required. You can get diseases from donating blood? Yes. Why yes? If
you get tested and you're a healthy person.
If you get tested and you are a healthy person, no. What? Yes. Yes, excellent. So this is excellent. Yes, if you are donating blood somewhere or in a hospital or that are not really following the right procedure, they're using the same needle, which doesn't happen usually, but you have to be careful. You have to be aware and you have to look at the type of needle that's being used. Yes, you can actually, if they reuse the same needle, yes, there is a potential, but this doesn't happen, of course, frequently. And finally, only adults that are really very strong, go to the gym on a daily basis, are the ones that can donate blood? No. So any healthy person, regardless, can donate blood. Thank you all.
Do we have any questions to Dr. Sima or the participants of the PBL, to our grade 8 classmates? A round of applause first to the grade 8 students. Thank you for a very informative session. Let's show our appreciation to Miss Nataline as well for her efforts. And also to Dr. Sima, who took the time from her busy schedule. Dr. Sima is also involved in the AGBU with our schools. You know, she is a member of our education committee. So this is a chance to thank her for her efforts throughout the years. Thank you, Dr. Sima. And we certainly hope we get the chance to see you again here. Thank you.